morning, afternoon, or evening. How y'all doing? Welcome back to Morrow's Math Corner. Today we're going to learn how to work with scientific notation. Scientific notation is a way of writing very large or very small numbers. It uses powers of 10 in order to represent decimal movement. Please note that positive exponents are used for original numbers that have an absolute value that are greater than 1. So whether it's a positive number or negative number, if the absolute value is larger than 1, then we have positive exponents in use. Please note that negative exponents are used for original numbers that have an absolute value that are less than 1 but greater than 0, or in other words, decimals. So decimals use negative exponents. How do we work with this? Step 1. We're going to go ahead and convert a number in standard form to scientific notation. And the way we do this is we first of all make the given number a value between 1 and 10 by moving the decimals either left or right depending on what kind of a value you were given. If you're moving to the decimals to the left, that means that you're working with values that are greater than 1, so you must use positive exponents. However, if you're moving decimals to the right, that means that you're working with decimal values, which are greater than 0 and less than 1, so you must use negative exponents. The best way to actually learn is by doing practice problems, so let's get right to it. I've got 22,300. The absolute value of that is larger than 1, so I'm going to use positive exponents. So I'm going to move my decimal value to create a value between 1 and 10. I'm going to move 1, 2, 3, 4 to the left. So I've got 2.23 times 10 to the 4th power. Done. Negative 1,250,000. The absolute value of that number is also larger than 1, so I'm going to use positive exponents. So when I create a value now between 1 and 10, I'm going to use my decimal by going 1, 2, 3, 4, 5, 6 to the left. So that's negative 1.25 times 10 to the 6th power. Now please note, we are going to the left, but I never really worry about if I'm going to the left or the right. I simply worry about what is the value of the original number. If it's larger than 1, I'm going to use positive exponents. Okay. Now, how about when we have decimal values? I've got 0.0023. This is a value greater than 0 but less than 1. It's a decimal. So when I create my value between 1 and 10, I'm going to use negative exponents. So I'm going to go 1, 2, 3 to the right. That is 2.3 times 10 to the negative 3rd power. 0.035, I'm going to go 1, 2 to the left, and I've got 3.5 times 10 to the negative 2 power. Now, yes, I know. When you go to the left, you're using positive exponents. When you go to the right, you use negative exponents. But trust me, it's not the best way to learn it. Learn it like I'm teaching it. If I have a whole number larger than 1, use positive exponents. If I have a value between 0 and 1, in other words, a decimal, here in pink, use negative exponents. Okay. Now we're going to learn how to convert from scientific notation to standard form. When a number written in scientific notation has a positive exponent attached to the base of 10, simply move the decimal of the given number to the right as many places as there are exponents. Fill in the gaps with zeros. When a number is written in scientific notation has a negative exponent attached to the base of 10, simply move the decimal of the given number to the left as many places as there are exponents and fill in the gaps with zeros. So let's get right to it. Convert each of these numbers written in scientific notation to standard form. I've got 8.3 times 10 to the positive fifth power. So that means I'm going to move this decimal 1, 2, 3, 4, 5 to the right. Place my decimal. Fill in the gaps with zeros. So I've got 830,000. Always clean up your answer. 4.2 times 10 to the negative 4. So that means I'm going to move my decimal 1, 2, 3, 4 places to the left. Place my decimal, fill in the gaps with zeros. So my final answer is 0.00042. Always clean up your answer. 0.375 times 10 to the negative 6 power. That means I'm going to move my decimal 1, 2, 3, 4, 5, 6 to the left. Place your decimal, fill in the gaps with zeros, and I've got 0.0000375. Please clean up your answers. 6.5 times 10 to the positive third power. That means I'm going to move my decimal 1, 2, 3 to, let's do that again. 1, 2, 3 to the right. Place my decimal, fill in the gaps with zeros, and I've got 6,500. It's that simple. All right, let's wrap this up. Last but not least, sometimes we are going to have to multiply or divide numbers that are in scientific notation. Please follow these very simple steps. Number 1, multiply or divide the numerical values. Then, step 2, multiply or divide the bases of 10. Remember to use your laws of exponents. For example, when you're multiplying, we're going to keep the base of 10 and add the exponents. Write the product or quotient in proper scientific notation. Remember that means that the numerical value must lie between 1 and 10. So let's get right to it. Multiply or divide each. 3 times 10 to the third times 8 times 10 to the sixth. First, multiply the numerical values. 3 times 8 is 24. Next, multiply the powers of 10. 10 to the third times 10 to the sixth. When the bases are the same and you're multiplying, you keep the base and add the exponents. Last step, we must convert this to proper scientific notation. That means I have to move this decimal 1 to the left. Please note that 24 is larger than 1, so I'm going to add 1 to the exponent, making it 2.4 times 10 to the 10th power. B. Got 15 divided by 0.3, which equals 50, times 10 to the negative 6 divided by 10 to the fourth. Please remember that when you divide the same base, you subtract the exponents, so that becomes 10 to the negative 10. This 50 must be converted to proper scientific notation, so I've got to move that decimal place 1 to the left. Please note that 50 is larger than 1, so I'm going to add 1 to the exponent, so this becomes 5.0 times 10 to the negative 9th, because I added an exponent. Okay, 240 divided by negative 3 is negative 80, times 10 to the, please remember that when you divide the same base, you keep the base and subtract the exponent, so that becomes 10 to the negative 7. Please remember that negative 80, the absolute value of that is larger than 1. So I'm going to have to move the decimal 1 to the left, and I'm going to add. Why am I adding? Because the original number was larger than 1. So negative 7 plus 1 becomes negative 6. And last but not least, we've got 12 times 11, which is 132. But you know what? Let's go ahead and change this up a little bit. And let's make this a 0.12 times 10 to the fourth and a 0.11 times 10 to the 12th. Let's go ahead and make that change because we haven't done that route yet. So when we do 0.12 times 0.11, we're going to get 0.0132 times 10 to the negative fourth power. Now, we've got to create a value here between 1 and 0. So I'm going to, between 1 and 10, sorry. So I'm going to move my decimal 1, 2 to the right. That becomes 1.32 times 10 to the negative 6th. Why, Moro? Please note that this value was greater than 0 but less than 1, so it's a decimal, so I have to use negative exponents when I make my decimal movements. I move 2 places. -4 minus 2 gives me my 1.32 times 10 to the -6 power. And there you have it. Hope you learned a lot. Thanks for watching. Come back anytime to Morrow's Math Corner. Thank you. Have a great day. Bye-bye now.